So there is a lot of folks out there who work on very interesting, deep problems that deal with a lot of complicated and deep data. Folks talking about news, doctors, oncologists, things like that. We as a company focus on the opposite end of things. We prefer the mundane. I don't know how many of you have transferred money recently. Raise your hand if you sent money transfer. Right, so we live in this world of digital customer experiences, real time, and have had the promise for instant digital real-time experiences for a long time. But in the real world, it doesn't work like that. So this is a screenshot from a European bank, but you can pretty much put any logo on this. And the point here is that in most cases, money transfers don't happen in real time. Sometimes it takes 4 days. If you look across all of this in the banking industry in particular, depending on the country, depending on the currency, you could be waiting 4 days, 3 days, 2 days, but it still takes a very, very long time and could be a very frustrating experience, particularly if you're buying a house or making a large purchase. And this is what I think is the reason for this. This is what I imagine the system behind this looks like. Probably more like this, right? Because it runs on a mainframe and is written in COBOL. But actually, there is a very good reason for this. In the United States in particular, this goes to very important development that happened now a while ago when following the 9/11 attacks, we had US Patriot Act introduced, which was aimed at targeting terrorism. But as a part of that US Patriot Act, there were additional requirements that were put on, in this case, financial institutions, but also other organizations to introduce additional reporting, do special due diligence, and do things like that were generally called anti-money laundering. And this, over time, became a bigger and bigger and bigger problem. So companies today are in need to do a lot of additional steps on top of just moving money from one account to another. That causes delays. Delays cause revenue loss. Regulatory fines are applied to these institutions. They end up buying a lot of, in this case, fraud detection software. And this is a very good example of this sort of problem where, yes, we live in a world of digital experience. Yes, we have, as consumers, mobile phones. But when we go to enterprise, particularly large enterprise, particularly organizations that deal at problems with scale, we actually end up with a lot of complexity. And what happens with that complexity in this particular case, and I'm just using this as an example, in order to do a thing like anti-money laundering, you end up doing different things like know your customer processes, enhanced due diligence, screening for sanctions, screening transactions. You end up buying a lot of software, in this case, various point systems to do all these various pieces. But you actually end up with a lot of manual labor in between. Because a lot of these systems are indeed running on mainframes. A lot of them don't have APIs. In fact, we can talk about data all day long, but in 80% of the cases, these applications don't have an API to access that data. And this is why people are introduced in the mix. People that do some physical work, in many cases, sitting in a swivel chair between two screens, moving data from one screen into another, maybe inserting a backslash in a Swift payment because that application runs on the mainframe and cannot be changed unless it's a regulatory change. But they also do a lot of cognitive work. Cognitive work where even the simplest data entry job requires intelligence because documents that go through these systems vary, volumes and velocity of those documents vary, and so this is why people are inside this mix. But of course, this creates a lot of complexity. Solutions become, in the end, point solutions. Shadow IT gets introduced to solve some of these problems. And we use artificial intelligence and machine learning as a company to solve for this problem. So we sell robotic process automation software as it is known today, this idea that we can create a robot that the person who is doing this manual work can train by just giving it examples of work. And then once the robot is trained, manage that robot or many robots, and through that, change the shape of these operations. Because we don't see this problem going away. In fact, with all the mobility, with all the apps, in this particular example in banking industry, the time that it takes a customer to onboard takes a bank to onboard the customer actually is going up. It's gone up 22% in 16, gone up again in 18%. And so on average today, it takes a bank 24 calendar days to add another customer. This is very far cry from the digital real-time experiences that we were talking about. And more broadly, banking is a good example because this is such a universal industry. But if we look at this problem more broadly, it's quite big, right? In healthcare, with revenue cycle management and other manually intensive operations, in retail, supply chain management, there are a lot of resources that are tied up in these manual processes. 25 million people in support functions, finance, accounting, HR, and trillions of dollars worldwide spent on these resources. And we today have technology to introduce benefits of artificial intelligence and machine learning. We don't need to invent any new algorithms. There is no need for any of that. If we were just to take what Chris talked about and made a self-service package that a business person can utilize in the real world, we can automate a lot of this work. Up to 20% of supplier costs can be saved. Accuracy of these processes can be introduced. Calendar time that it takes to complete these transactions is going to go down. And so it's a vast opportunity that can unlock a lot of growth. And the reason why this happens is, this is a study from McKinsey, but the real world is complex, right? So we could talk about different systems that we have, but in reality, fully 1/3 of use cases in the enterprise require at least a monthly change, and 25% of the cases require a daily change. This is why it is impossible to attack these problems with coded software. So any software that was written and requires a code change is a non-starter for at least 1/3 of the problems that enterprise really faces. And in fact, even if that change can be made quickly, just the process of putting that software into production is very lengthy. In typical bank, it requires more than 100 steps, but even in unregulated industry, it's quite long. And we think that artificial intelligence and machine learning can help with that. Instead of writing code and then pushing that code into production to deal with whatever the change, new type of customer, new product, new template of the document, something happened in the real world, we can have systems running that adapt to these changes. They can learn from how people do this work and then repeat it much faster with higher accuracy, lower cost, the economics of software versus the economics of people. And that moves us from the old paradigm to the new paradigm, from what we call software 1.0 paradigm. This is the world of traditional SAP and Oracle, where you spend 5 years and $5 million creating a new workflow, and you put all of these teams and you push it into production, to now a world where we have a lot less code, and most of the system is composed of the data that is flowing through these business processes, and the system is able to be created in the much smaller packages, much faster, and can adapt to the real world. And this is a famous example of Google Translate, where it was 500,000 lines of code and a little bit of data, and the new version of Google Translate has 500 lines of TensorFlow code and tons of data in it. So it just moves the paradigm very different, comes with very different life cycle of how these systems are actually used, and so as a result, changes how people operate. Because AI can be very difficult. What Chris talked about at New York Times, we do think that there are deep problems, fraud detection, underwriting, that still require data science teams. And New York Times is a very focused organization, and so we definitely see in that case. But we also see kind of a T-shaped, good enough, but across all of that enterprise need for application of artificial intelligence and machine learning, and we've conceptualized it into this idea of a learning robot, right? So that business operations teams can do it themselves. Because if you don't make it self-service, you need lots and lots of data, you need clean data, you need complicated technology, all these different roles, data engineers, data scientists. I don't know, people come from all kind of geographies here, but in New York, all of these folks are expensive and very hard to go by. So we think that there should be another answer. So in this world of data is the new oil, which is the famous saying, we actually think that the training data is the new oil. Because in most cases in the enterprise, we do not have million articles tagged, lying around. In the real world, we need transaction to be processed today, insurance claim comes through, it needs to be settled in 72 hours, otherwise you get a penalty. You don't have time to set aside for these subject matter experts to do all of it. And we think with artificial intelligence and machine learning, there is a real change that has happened, particularly in the past 3 years, that makes this all possible. Because we all heard about unsupervised learning, things that Amazon, Google, Facebook do in the cloud, take tons and tons and tons of data, and then turn it into insights. But that is not available to a retailer. It's not available to even a telco company in many cases. And so what ends up happening is that people label data and do what is called supervised learning, where your subject matter experts annotate every article, annotate every transaction, annotate every page. But then we had active learning, where we could annotate not everything, but things that are most useful, thereby reducing dramatically the number of examples that are needed. Then we started to see applications of semi-supervised learning, where we're also using the knowledge that subject matter experts have about the structure of the data to further reduce it, essentially supplementing neural networks with business rules. Of course, now we have transfer learning and differential privacy to be able to take a model that has been trained on one type of document and move it to another type of document within an organization, or maybe to even another organization, while respecting data privacy laws. So now we can ensure that there is no data moving from one customer to another. And now we are getting to what is today known as weak supervision, which is this idea that we can now, in a much more sophisticated way, combine lower quality labels. So you can do it very, very quickly with the teams that are not as expert. You can combine that with these pre-trained models that are coming from another part of the organization or from another customer, and you get a degree of automation right out of the gate. And you have your subject matter experts focus on just the highest quality knowledge. So the system can point them which specific transactions or documents a subject matter expert needs to look at. It's going to ask the questions, and the subject matter expert can provide information about format, distributions, how often this happens, and through that reduce the number of samples even further to like a real world where you don't have 1,000 documents lying around perfectly annotated. You have maybe 50. And this kind of changes everything. This is the difference between electric car being 10x of the combustion car to the point where electric car is starting to cost as much as the combustion car costs, and so creates real incentives to change. So if data science project is 10 times as expensive relative to hiring a person, nobody's going to do it. People are just going to hire people because it's just easy. But when we have parity of how long does it take for a bot to be trained relative to how long does it take for a person to be trained, we are starting to enter a different realm. Because in many cases today, it takes 6 to 8 weeks for a new associate to go through training, could be even 2-3 months before they can complete transactions in production, before they can move the money for the bank, before they can put an order to a supplier. And if we can train the bot in about the same amount of time that it takes for a new associate to be trained, we are starting to talk about different economic models. So let me kind of stay in the banking and give you another example. I don't know how many of you are aware of, but in order to open an account, and most banks are trying to create an experience of the fact that the account is opened, you actually need to look at who is behind that account. And if it's a company, you need to look at who are the stakeholders, who is on the board, who owns the company, what other companies does this company own, and you, by regulation, need to go and look for information about these stakeholders. Are there articles, news articles? Did New York Times say something about that person or not? Were they involved in embezzlement, or are they sources of funds or in Korea or North Korea or other sanctioned environment for the United States? And if you're opening many accounts, we see customers today where they have hundreds of people around the world just reading articles. That's the job. You're supposed to find who is behind this company, Google for articles, or go to Factiva or some other system, read these articles and try to understand whether the article is negative in nature or not negative in nature. And it's a complicated job because the rules are unclear. And so it takes a while for the person to be trained. Plus, many systems are involved, right? So they need to go into 38 CRM applications that the bank or an insurance company has. They need to go and look for articles from different sources to comply with regulatory requirements, but also specialized requirements that each institution has for this. Of course, this is gonna get heavy, very costly. You get penalties. But we can actually train the bot to do the same thing. So this is a screenshot from Workfusion interface where this sort of task has been configured in the system. System can use robotic automation to pull the data from whichever source. It can go to the API, or it can literally look at the screen of what the person is looking at, and through the screen, through the pixels, extract the data. It can present the data to a user and ask a user, should we open a case for an investigation, or is this article fine? And the user, first time, provides a little bit more information that person is involved in a Ponzi scheme. Case needs to be opened. You can't just open an account. They give another example that maybe some fraudulent activity has been involved. And after 50, 100, 200 repetitions, we actually now have a bot doing this work. So a person doesn't go looking for these keywords. In most cases, the bot can prioritize the work, determine the nature of the article, open the cases where there is high degree of confidence that's required. And this is just one task. But we have, in our company, focused on business operations. We focused on the needs of large enterprises. We looked at all the transactional work in back office, middle office, and took all the tasks that exist. Because there is a finite number of things that people do. We inventoried them in our system, and we've created a system that can automatically train bots on these sorts of tasks. And so people configure these tasks like they would for, as an example, for a new associate. They just run them, and our system in the background trains artificial intelligence models to repeat that task. Once it knows that the model matches the performance of a human, it starts to send some work to a bot, some work to a human. And so we get a combined workforce now where people are not completing the tasks, but they're training bots. And then the bots complete all the mundane tasks, go into the systems and making decisions. A lot of manual work gets eliminated. Outcomes get improved. And people start to focus on analytics. Because we think that same things will happen in business operations, same thing will happen in the back end of your enterprise that happened in marketing. Marketing used to be also very manual discipline. What we talked about, personalization, targeting of ads, that's very new. Today, marketers orchestrate email campaigns, segment audiences, determine sentiment. 15 years ago, there was stuff in envelopes in many cases and buying ads manually. We think that the same thing will happen to chief operating officers across the world and to their operations. That manual work will get replaced by real-time learning systems that will be able to react to the world as it changes. And folks will be looking at the accuracy of those business processes, why the mistakes are happening, how can we address those mistakes, orchestrate workloads across their enterprise, sending them to the right source. So much like what has happened to servers in the case of Amazon, where we no longer know where those servers are, we no longer know, where they're located. You can just pick what country it needs to be in, and then everything else gets deployed by Amazon. We think the same will happen to manual work. Those workloads will be software orchestrated, driven by software, and operations teams need to focus on higher value tasks, analytics, determining what's best for the business, finding counterparties that may be sending you this bad data and go and talk to them, look at the process, understand additional data about the customer, give them better products, reduce risk, improve compliance. And what will happen is instead of 20 million engineers that exist today in the world, there is not a lot of them. There's only 20 million people coding in all of the world. There's 3 billion knowledge workers out there. We think what AI does is it actually helps converge those universes. So yes, some of the more difficult problems will still need to be solved with code. These software platforms like ours need to be written, but we think that 3 billion workers will become 1 billion intelligent automators, data programmers, whatever people use different words for this, but they will essentially create software systems not by writing code, but by giving intelligently examples of work and then orchestrating the behavior of the system. And that is a fundamental change, and a change that is very worthwhile because obviously the stakes are high. If we were to continue to grow global economy, we need to find for ways to increase productivity. Productivity has really been stale over the last couple of years, and in order to avoid many of the socioeconomic issues that we have today, and in order not to have big recession, we need to find ways to continue to grow, and this is one way to help. The idea of a real-time learning robot that learns from the person, lowers the threshold for business operations to be able to start creating software systems themselves, gives people one self-service platform that doesn't require them to master 20 different tools, one for analytics, another one for workflow, another one for machine learning. We think all of that can be wrapped in one neat package. And that is what will change the operating model for the enterprises. So instead of just coded systems or people, we will have a new option in the middle that combines the best of each. In this idea of digital operations to complement the digital experiences that we want to have. So that money transfer that I talked about in the beginning of my talk will deliver on the promise of that experience so that it won't take 4 days to complete this. So this is the end of my talk. I think we have time for maybe a couple questions. Thank you.